Hello dear friends, and welcome to another electronics video. Today we are going to be discussing a Arduino RGB LED VU Meter. So the target for this design is to drive at least 10 RGB LEDs. The input signal shall be independent from the audio amplifier, so this could be a splitter on the audio input from a PC or any other audio signal. And the LED shall be turned on depending on the input signal levels. So as the amplitude of the audio signal is increased, this is then increasing the number of LEDs that the LED strips. As an architecture, we're going to have an external power supply. Here I placed a 5 amp 5 volt power supply here, and of course we're going to have an Arduino board and a LED strip. You can add ring strips, single LED strips. You just have to define the number of LEDs, so this will be scalable on the number of LEDs you are going to be using. Okay, so let's get to it. So let us open TinkerCad and create a new circuit. Here we have the dashboard where we are going to add our components. So let us add our Arduino. So first of all, go components all. Let us add an Arduino board, Arduino Uno board. We are also going to require a LED strip. Here you can find rings, different types of rings, but we're going to take a simple LED strip. Just that we analyze a bit our LED strip. So the LED strip has an input signal, a 5 volt supply, and a ground signal. Okay, and of course we are going to need a signal generator so that we can generate the signal to drive this circuit. So I'm going to place a signal generator and of course a power supply so we can drive everything from this power supply so that we don't burn out the Arduino board. Okay. So first of all, let me connect the ground between this the power supply and Arduino, and then of course we will have to connect this to the 5 volt input here, the ground from the LED strip also to the ground from Arduino, and now we have supplied the LED strip. Next we have to also connect the ground from the signal generator to the Arduino board so that we have the same ground everywhere, or voltage reference. And the 5 volts know the analog 0 pin that we're going to be using to drive this circuit. Okay, so coming back to the circuit, last connection that we need to make is the data in or the in pin. We have to connect it to the Arduino in order to be able to drive this this LED strip, and of course set the color for each LED strip. Now all the connections have been made. The power supply, signal generator, Arduino, and LED strip all have the same ground. Let us go to the coding side of the video. Now let's switch to text. Yes, I am sure I want to continue. Of course, here we have a standard example of Arduino test code. This is just switching this LED on and off each 1 second. But we are going to delete everything here. And of course, we're going to start by including the Adafruit library. Include Adafruit NeoPixel.h, and let's define first some constants. So define the pin that we are using to drive So we're going to use pin 1 to drive the LED. And then let's also define the number of LEDs, which would be in our case 10. And let me move these to look a bit better. Okay, let's create some global variables like the signal value, or what we are taking in from the signal generator. In our case would be the audio signal, so signal value. And let's create a variable for the number of signals, or LEDs, number of LEDs that we are going to open at a certain time. So for example, a certain amplitude will have a certain number of LEDs. And then also let's create a global variable I, which is for all we're going to use it as a counter later on. Okay, so first thing we have to do in our code, so this is just the initialization part. Let us start and create the object for the LED strip. So Adafruit underscore NeoPixel strip is equal to Adafruit underscore NeoPixel with the following parameters. So the first one is the number of LEDs. Second one is the communication pin, and of course the type of LED. So Neo GRB plus Neo KHZ 800. Okay, so now we have initialized the LED strip. Let us create the setup function. So void setup. So this is only run at the beginning of the code. So void setup strip, of course, begin, so that we can start the strip. And of course, let us also define pin A0. So pin mode A0 as being the input pin for the ADC that we're going to use to convert the audio signal into a real life value in the microcontroller. So next, void loop. So this is the infinite loop where we are going to be running our code. And here we are going to, of course, read from the ADC. So first of all, we are going to signal value. It's going to be the value that we're going to read from the ADC. So analog read from pin A0. And then we are going to be of course, scaling this to the number of LEDs. So number of LEDs here. I'm going to convert this all to int. So usually this is a conversion between the signal value and the ADC value. So I'm going to write signal value times 10 divided by 51. And let me explain why this is. So we are going to have 10 LEDs and we are having 51 here. So the signal value that we get from the ADC is a value from 0 to 255. And we need to convert this value to represent one of these LEDs. So as the value is higher, we need to turn on more LEDs. So in this case, the 51 here, the 10 means the number of LEDs. The 51 means the value from 255 that we're converting. But most analog signals or signal sources from a headphone amplifier, they're kind of 0 to 1 volt amplitude. So this means that we are going to read here only 0 to 1 volts, but 0 to 1 volts is from 0 to 51 in range, because it's 0 to 1 is 51, 0 to 2 volts would be 102, 0 to 3 volts would be 153, and so on, multipliers of 51, which is the equivalent in the ADC conversion for 1 volt. And then let us create a function now. So now we know the number of LEDs we have to light on. We know what we have to do. Now we just have to create a set LED color function here. So now we're going to define the color for the LED. So first of all, in the first instance, we are going to make all colors blank, so turn off all LEDs, and then we're going to give it a color. So each time we're going to run this function, we're going to clear the LED strip, and then we're going to give it a new color. So for I, which is our global variable, I less or equal to the number of LEDs, I plus plus, we are going to turn all the LEDs, so strip dot set pixel color to 0 so what pixel are we going to set? We're going to set pixel I to the color strip dot color 0 0 0. So this is actually, they are closed. There is no color going through it. So with this, we go through all the LEDs, and then we're setting everything to 0 0 0. Great. Next, let us create another for loop to turn on only the number of LEDs that we want. So I equals 0 to I is less than equal to the number of LEDs that we have defined above, LEDs. Okay, and we are going to increase I plus plus. Okay, so first of all, let's create a bit of a different types of LEDs. So let's not just turn them all on with one color. Let's say, for example, we have 10 LEDs. We turn the first 2 with one color, and the rest of 6 with another color, and the last 2 with red. Let's say this means the highest output level. So let's create like function to separate between these types of colors. So let's say E less than 2. For example, if this is less than 2, we are going to set strip set pixel color. I'm going to copy this from here. I'm going to copy all of this from here, and I'm going to put it here. So for I, we want to give it a blue color, so 255. Okay, now I put a breaking point here by accident. So then if we are E is less than or it's greater or equal to 2, and I is less than 8, because here we are at the maximum limit, we're going to make this green. So 255 here. This is green, so this is red, green, and blue. This is how you determine the color. And for the last one, so if I is greater or equal than 8, as we had before, but also smaller than 10, we are going to make it red here. Okay. So now that we have written this function, let us use it. So set LED color. So now we're just setting the color for the signal value, and let's display this. So strip.show so that we can see our code in action. And of course, we need to add a delay. If not, this would run frantic with very high refresh ratio. So with the delay, you can play a bit. So let us start the simulation and see how this looks. Okay, we have a error here in the code. Okay, so here I made a mistake. So let us copy. Oh, signal. Okay, signal value. I just went over it a bit fast and I made a typo. Okay, so now we can see the input signal is fluctuating. And let us also define, so here we are going to use, let's use a 1 volt, not square, we are going to use maybe a sine wave would be most accurate for the audio field, and no offset. So okay, so this is the signal. Let us also add a oscilloscope just that we can see how the signal looks. So all components, let me add a oscilloscope, and we just have to look and see, okay, how is the signal looking? So negative goes to ground, okay, and positive goes to pin A0, okay. Okay, and pin A0. Let us start this. Okay, and our signal looks like this, and this is quite fast. It's a 1 kilohertz signal, so I don't think this is too big as a frequency. Let us add a smaller frequency so we can see it on the oscilloscope. Here we have 1 second, so this would not this is not accurate from the oscilloscope point of view. The oscilloscope tool is not that great in this software, but because it does this automatic scaling. So now we can see our signal goes from 0 to 1 volt here, and then we can see it how it turns on and off here. And if we want to add, let's say, more LEDs, or let us do something a bit different. So let us just add a LED ring. So we don't want to add another strip. Let us add a LED ring. So I'm going to put this ring over here. The input has to go into the output from the previous LED strip. Then we just have to modify the code a bit just to get it working correctly. I'm going to take the ground from this pin, so ground from our already available LED strip, so ground, and power also from here. And now, based on this configuration, you can put as many strips and rings and lights, just that you collect the data out from one LED strip to the other one so that they are serialized. This could make, yeah, kind of all the difference. So this is I think, let me go back, this is a 12 ring. So let us add here the number of LEDs. Let's place 22, because we have already this 10 plus 12 on this one. And Of course, let us modify the code. So here we want to, the number of LEDs have changed. Let's see what we need to do in order to run this. So this is running perfectly here. It is going to maximum, but we need to optimize here the difference. So let us put here I less than, let's say, 4, green from 4 to, let's say, 18, and from 18 to 22 we have red. Okay, let us see how this is working. So you can see this is working quite well. You can see all the LEDs lighting up also on the LED ring, and it's a nice simple project. It has a lot of interesting applications. You can also play with the scale here, so you can play with the scale here. So if you have a very low input signal, maybe 0.5 volts, you can decrease this to 25. But in our case, I'll like put here 25, and we can do this 25, and we can go here in the power supply and put 0.5 volts, and then of course it runs similarly to the previous code, just that our input signal is much lower. That being said, I hope you enjoy this project and wish everybody a great day.